Hello everyone, today we're going to be covering another tutorial in Jamovi, today specifically focusing on an ANOVA called a Mixed Design ANOVA. In this tutorial, I'm going to show you what a Mixed Design ANOVA is, the kind of research question that you might ask to use a Mixed Design ANOVA. I'm going to show you how to test the assumptions of this kind of ANOVA in Jamovi. I'm going to show you how to conduct the main analysis of the ANOVA in Jamovi, and then importantly, I'm going to walk you through how to interpret the results of the output, because there is quite a bit of it. So I've got the data available for you to download in the description below. Go ahead and pull that up so you can work along with me, and let's get into it. So first I want to talk about what a mixed design ANOVA is. So it's referred to as mixed design because we have both a within subjects factor and a repeated factor. So if you've seen any of the other tutorials, we've talked a little bit before about the difference between a within group design and a between groups design. I'll go over that with you here briefly. So a between groups design is when we are looking at differences between groups that are independent of one another. So we might have a group who gets therapy and a group who is on a wait list, right? The people in those two groups don't overlap. It's a between groups design. A within groups design is where we have the same or highly matched group of people or data, and we look at the differences between that group of data over time or in different scenarios. So when we have something called a mixed design, that means we have both a between subjects and a within subjects factor. So our example that we're going to be working with today is we want to look at the differences between behavior outbursts for kids who are in therapy over time. So we're going to measure them before they go to therapy, after they've been in therapy for a little while, and then again after they've been in therapy even longer. That is a typical within subjects design, right? We've got the same group of kiddos and we're measuring them at 3 different time points. However, what makes this a mixed design ANOVA is that in addition to looking at change over time for the kiddos that are in therapy, we're also going to be looking at change over time for people who are just on a wait list. So we've got a group of people, we're dividing them in, some people are getting therapy, some people are going to be on a wait list, and everyone is going to get measured across 3 different time points, making this a mixed design because we have that within and between subjects factor. So to be able to take a look at what this would be like in Jamovi, we're going to go to Analyses, then ANOVA, and you're going to select the Repeated Measures ANOVA tab. And this is because since there is that within subjects factor, the Jamovi software requires us to be working within that Repeated Measures tab. So you're going to click on that. Then under Repeated Measures Factors, Jamovi allows you to label. So since we're looking at behavior outbursts over time, I want to have you label that as time. However, if you have a different label that you'd like to put, you can quite literally put anything. So I'm going to go ahead and write time here, and then I'm going to fill in the rest. I have 3 time points. I'm going to call them time 1, time 2, and time 3. And you'll see that that terminology will auto-populate into the next tab there, the repeated measures cells. So then I'm going to move over outbursts at time 1, 2, and 3 into those corresponding cells so they can have all of that aligned. Now we also have a between subjects factor here. So I'm going to move over the variable intervention status, and that's going to indicate my groups that are either in therapy or on the wait list. Then for effect size, I'm going to have you select for partial eta squared. Now, we have to conduct a couple of different assumptions before we can really get into analyzing the meat of this analysis here with the ANOVAs. So one of those is something called sphericity. This is sort of like homogeneity of variance for within subjects designs. So you're going to ask for the sphericity test, and it's going to give you a Mauchly's W value with an associated p-value. We would like to see for that p-value to be greater than 0.05. That would indicate that we have met the assumption. However, here it looks like our p-value is less than 0.05, it's even less than 0.001, indicating that we have violated sphericity. And you'll see that this is actually fairly common in within subjects designs, and so Jamovi already has built in for you to be able to correct that using a correction factor. So I'm going to go over to sphericity corrections, and I'm going to select the greenhouse geyser correction factor, and you'll notice that auto-populate in your output. That's going to correct for the fact that we have violated that assumption of sphericity. Next, we're going to take a look at homogeneity of variance. Like I said, sphericity is like homogeneity of variance for within subjects design, but we also have a between subjects factor here. So we need to also take a look at homogeneity of variance or Levene's test. And again, we are looking for p-values that are greater than 0.05. And so when I take a look at the results here, it looks like we are good to go. None of these p-values are less than 0.05, so we have met the assumption for homogeneity of variance. Lastly, we also need to take a look at normality. Normality here we can test with a QQ plot. And what we're looking for here visually is that the dots along the line should fit pretty closely to that line. And we do see that here for the most part. Maybe slight deviations there on the tails, but nothing concerning, especially since we do have a robust sample size. The rule of thumb is that sample sizes above 30 can approximate normal according to the central limit theorem. And so we are well above that. So we can say, okay, it looks like normality is also good as well. The final assumption that we actually don't test in Jamovi is that of independence. This is an important assumption. It states that the data or groups of data are independent from one another. We would typically take care of this and make sure that we're good there in the research design and data collection portion of the process. So we've tested sphericity, homogeneity variance, and normality within Jamovi. We've made the correction factor where needed, and we are good to continue with the rest of the analysis. So I'll scroll back up, and we do have quite a bit of output here, so I want to take some time to go through it. So we looked at the role of time and the role of intervention status. So we have, again, between subjects factors and within subjects factors. And you'll see that Jamovi will parse those out in the table. So the first table is going to be all of the within subjects effects. So you're going to have time and then the interaction between time and intervention. So you'll get your typical sum of squares, degrees of freedom, mean square, F, and P, and then we also have the effect size here. So we're going to take a look at these p-values, and we see that both are indicating statistical significance. So the effect of time is statistically significant, and the effect of time and intervention status, so that interaction, is statistically significant. And if we take a look at these partial eta squareds here, they're explaining around 70-ish% of the variance in outbursts that the kiddos are having. So that's quite a bit of variance explained there. And then if we scroll down just a bit and look at the between subjects effects, we'll also see that the role of intervention status is statistically significant, with an effect size of around 17.6% of variance explained. So anytime that we have a statistically significant interaction that has more than two groups, we need to conduct post-hoc testing on that interaction. I know you might be thinking, well, what about the main effects? We have a statistically significant effect of time and a statistically significant effect of intervention. Yes. However, when we have a statistically significant interaction, we don't conduct post-hoc testing on the main effects. We just conduct post-hoc testing on the interaction. And the reason for that is because our assessment of what's happening with the main effects can be skewed when we have a statistically significant interaction. So we know that some combination of both time and intervention is statistically significantly impacting outbursts. So we're going to conduct some post-hoc testing to figure out what exactly is going on there. So you can scroll down to post-hoc tests, and you're going to move over the interaction effect of time by intervention status. And then I typically use the Bonferroni correction. All of these correction factors are doing very similar things. They're trying to control for the type 1 error rate inflation that happens when we conduct multiple analyses. So if you prefer Tukey or Chaffee or something else, feel free to select that instead. Your interpretation will be fairly similar. So I'm going to select Bonferroni. And then you're going to see that there's quite a few pairwise comparisons happening here. So we have 3 different time points, and then we have waitlist and therapy intervention status. So we're looking at all of the different combinations of those interactions there. And if we scroll over, we'll see that we can look at the Bonferroni adjusted p-value. So this p-value here has already been corrected for the fact that we're conducting multiple analyses. You might notice that sometimes the p-value will be exactly 1. And what happens there is anytime, because of the formula for the Bonferroni correction, the p-value would be greater than 1, which is not quite possible. So it caps it there and just says it's 1. So those are not statistically significant, of course. But we do have a couple of pairwise comparisons that are statistically significant, all of them at the p is less than 0.001 level. So that's pretty neat. What we want to do to understand what's happening even more here is take a visual examination of the data. So I'm going to have you go down to estimated marginal means, and I'm going to have you create the term for the interaction. So you're going to include time and intervention status in term 1, and they're going to be in that order. What I always recommend when trying to wrap your head around the plots of these interaction effects is to ask for the plot both ways. So when I put time first and then intervention, I'm going to then create a second term and put in intervention status first and then time. That's going to flip the axes for those variables so I can look at the same data but put into 2 different ways. And sometimes that just helps better understand what's going on. Maybe one of the plots will make more sense to you than the other one, but they're saying the same thing just in different ways. Then you're going to make sure you ask for both the plot and the marginal means tables. And then here, there's a section where you can ask Jamovi to include error bars, and it typically includes those automatically. But I actually typically go in and select none. And the reason is that it just adds another piece of visual information onto the plot that already has a lot going on. So I find that I have an easier time reading the plots when I don't also have the error bars. But that's ultimately a personal choice, and you can select to leave them in. So now let's take a look at the plots that we have. So we can see here with the plot, the first way that I asked for it, time and intervention, we have time on the bottom and then intervention status as the 2 lines. And we can see at time 1 for waitlist and the therapy folks, their number of outbursts is really close to each other, right? It's about the same. Kids in these groups, they haven't received the intervention yet, so their outbursts are pretty even. Then as they start receiving the therapy intervention, the kids in the therapy group outbursts start to decrease. So now we see a bigger difference between the 2 groups, the waitlist group and the therapy group at time 2. And then at time 3, we see an even larger difference. So now again, the therapy group outbursts have decreased and the waitlist group has stayed about the same the entire time, which makes sense. Nothing is changing, so nothing is changing. So then if we wanted to, we can go ahead and take a look at that same data, but put differently. So now we have waitlist and therapy on the bottom of the plot, and then we have the 3 lines are the 3 time points. And we can see that these plots are saying the same thing. So for the waitlist group, time 1, time 2, time 3 are all really clustered together because nothing has happened. Those folks are all on the wait list. They're not receiving any kind of intervention. So the children's outbursts are staying the same and they're staying relatively high. But then if we look at what happens with the therapy group at time 1, the difference between waitlist and therapy is pretty much the same. That line is almost a flat line. Then we start to see some changes in time 2 and even more in time 3. So same results as the other plot, looks slightly different, and sometimes that can help us interpret it a little bit better. Another thing that you can take a look at as well is we asked for the information in table form. So you can take a look at the mean, so the average outbursts at the different time points for the different intervention groups. So at time 1 for the waitlist and therapy group, both of those kids are having an average of like 20 outbursts. That's quite a bit. But then when we get all the way down to time 3, the waitlist kids are still averaging about 20 outbursts, but the therapy kids have pretty much halved that to less than 10 outbursts. So you see, we've got not only is this statistically significant, we've got the effect size from the partial eta squared, then we also are taking a look at the interaction effect in the plots and the differences in means. And all of that information together really helps us to have a better understanding of what exactly is happening with our data. So we have tested the assumptions, we've run the analysis, we've done our post-hoc testing, and we've talked about what this output means. If you have any questions about it, please feel free to reach out to me. You can make a comment on this video, or you can reach out to me at ajoytoteach.com and I'll be happy to help you further. Thanks so much.